Imagine a moment in history when a soldier or hunter had to fire a weapon, then stop, manually reload a single round, and prepare again before firing the next shot. In intense situations, those few seconds could mean the difference between victory and defeat, survival and danger. Over time, firearm technology evolved to solve this problem, leading to the development of repeating firearms, guns designed to fire multiple rounds without needing to reload after every shot. The key to this advancement lies in a clever mechanical system that chambers the next round automatically or with minimal manual effort. These systems include lever actions, bolt actions, pump actions, and semi-automatic mechanisms, each designed to move a new cartridge into the chamber quickly and efficiently. To understand how these mechanisms work, it helps to first understand what chambering a round actually means. Inside any firearm is a chamber, a small space where a cartridge sits just before it is fired. When the trigger is pulled, the firing pin strikes the cartridge primer, igniting the powder inside and propelling the bullet forward through the barrel. After that shot is fired, the empty casing must be removed and a new cartridge must be moved into the chamber before the next shot can happen. The innovation of repeating firearms is the mechanical action that performs this process repeatedly and reliably. One of the earliest and most famous mechanisms is the lever action system. Lever-action firearms became especially popular in the 19th century and were widely used in the American frontier. A lever located beneath the rifle is pulled downward and then pushed back up. This motion performs several tasks at once. First, it ejects the spent cartridge casing from the chamber. Second, it loads a new round from the magazine tube into position. Finally, it locks the chamber closed, making the firearm ready to fire again. This process happens quickly and smoothly with practice, allowing the shooter to fire several shots in rapid succession without stopping to manually reload each cartridge. Lever-action rifles became iconic due to their speed and reliability, and they remain popular for hunting and sport shooting even today. Another important mechanism is the bolt-action system. Bolt-action firearms are known for their strength, accuracy, and reliability. The bolt is a metal cylinder located inside the firearm's receiver, connected to a handle on the side of the weapon. After firing a shot, the shooter lifts the bolt handle upward and pulls it backward. This movement extracts and ejects the empty cartridge casing from the chamber. Then, when the shooter pushes the bolt forward again and locks it down, a fresh round is pushed from the magazine into the chamber. Bolt-action rifles are often used in military sniper rifles and precision hunting rifles because their design allows for strong locking of the chamber, which helps handle high-powered cartridges and maintain consistent accuracy. Pump-action firearms use a different type of motion but achieve the same goal. The pump-action system is commonly found in shotguns. Instead of a lever or bolt handle, the shooter slides a fore-end grip located under the barrel backward and forward. Pulling the pump backward ejects the spent shell and prepares the mechanism for the next round. Pushing the pump forward loads a new shell from the magazine tube into the chamber and locks the firearm ready to fire. Pump-action shotguns are widely known for their durability and versatility. They are used for hunting, sport shooting, and certain military and law enforcement roles because they can handle different types of ammunition and function reliably even in harsh conditions. As firearm technology continued to evolve, engineers developed semi-automatic mechanisms, which represent another major leap forward. In a semi-automatic firearm, the energy produced by firing a cartridge is used to automatically cycle the action. When a shot is fired, the force of the expanding gases or the recoil of the firearm moves internal parts that eject the empty casing and chamber a new round from the magazine. This means the shooter only needs to pull the trigger again to fire the next shot, without manually operating a lever, bolt, or pump. Semi-automatic firearms are common in modern rifles, pistols, and certain military weapons because they allow faster follow-up shots while maintaining control and accuracy. Although these mechanisms differ in design, they all share the same basic goal, ensuring that a fresh cartridge moves into the chamber quickly and reliably after each shot. The internal process involves several steps working together in precise timing. First, the spent casing must be extracted from the chamber. Then it must be ejected from the firearm, usually through an ejection port on the side. Next, the magazine pushes the next cartridge into position. Finally, the mechanism moves forward to chamber the new round and lock the action closed, preparing the firearm for the next shot. Every part must work smoothly, because even a small malfunction can interrupt the firing cycle. Magazines also play an important role in repeating firearms. A magazine is the component that stores multiple cartridges and feeds them into the chamber one by one. Some firearms use tubular magazines located under the barrel, which are common in lever-action rifles and pump-action shotguns. Others use box magazines, which are rectangular containers that hold cartridges in a stacked arrangement. Box magazines can be internal, built into the firearm, or detachable, allowing the shooter to quickly replace an empty magazine with a full one. The magazine works together with the firearm's action to ensure each new round is positioned correctly for chambering. Reliability is one of the most important factors in any repeating firearm mechanism. Whether it uses a lever, bolt, pump, or semi-automatic system, the firearm must function consistently under various conditions such as dirt, dust, extreme temperatures, and rapid use. Engineers carefully design springs, locking lugs, extractors, and feeding ramps to ensure smooth operation. Over decades of development, these mechanisms have been refined and improved to handle more powerful cartridges, reduce recoil, and enhance durability. Another key factor is speed. The faster a firearm can chamber the next round, the faster a shooter can fire again if necessary. Lever-action and pump-action firearms allow skilled users to cycle the action very quickly, while semi-automatic firearms can chamber rounds almost instantly using the energy from each shot. Bolt-action firearms, while slightly slower, often provide exceptional accuracy and control, which is why they remain preferred for precision shooting. Safety is also an important aspect of firearm design. Modern repeating firearms often include safety mechanisms that prevent the weapon from firing unless the trigger is intentionally pulled and the action is fully locked. Some designs also include features that prevent the firearm from firing if the chamber is not properly closed. These safety systems help reduce the risk of accidental discharge and ensure the firearm operates as intended. The development of mechanisms that chamber the next round efficiently has had a significant impact on military technology, hunting practices, and shooting sports. Soldiers benefit from firearms that allow multiple shots without constant reloading, hunters can make quicker follow-up shots when necessary, and sport shooters enjoy smoother and more efficient shooting experiences. The underlying principle remains the same, using mechanical or automatic action to move the next cartridge into the chamber after each shot. Today, firearm engineers continue to innovate and improve these mechanisms. Advances in materials, manufacturing techniques, and engineering design have made modern firearms lighter, stronger, and more reliable than ever before. While the basic concepts of lever, bolt, pump, and semi-automatic actions were developed many decades ago, they remain the foundation of many firearms used around the world today. Understanding how these mechanisms chamber the next round reveals just how much precision engineering goes into firearm design. What appears simple from the outside is actually a complex sequence of movements happening inside the firearm in fractions of a second. Springs compress and release, metal components slide and lock, and cartridges move smoothly into position, all working together to ensure that the firearm is ready for the next shot. This combination of mechanical ingenuity and practical function is what makes repeating firearms such an important milestone in the evolution of weapon technology. By allowing multiple shots before reloading, these systems transform the way firearms are used in many fields. From the historic lever-action rifles of the frontier to modern semi-automatic platforms used by militaries and sport shooters, the ability to chamber the next round efficiently remains one of the most essential features in firearm design.